If two books of width W are stacked at the edge of a table so that a part of each book is over the edge, what is the maximum distance the top book can be over the edge? Where what we mean by that is kind of like what is the maximum extent to which the top book can kind of reach over the edge. In other words, this distance D here, where we're given again that defined width W for each of the books. So to answer this question, I think I'm going to focus on that top book first a little bit. So let me try to draw a picture of that top book here, approximately. All right, so let's say this is that top book here. Okay. And that top book, in order for it not to tip over kind of this edge here of the top kind of left edge of the book right underneath it, the farthest I think it could be is halfway over. And that's hopefully intuitively obvious, but from like what's the physics principle there is we could say, hey, if this is the center of mass point of that top book, if that goes outside the base of support for that book, then the book would tip. That's when it would be out of balance, right? So let me draw on this bottom book here. I don't know how accurate these pictures are of books, but they're better over there on the slide, right? Okay, so here's the bottom book. Now, didn't turn out so good at that end, but whatever. So again, I said this one, could be halfway over. So in that sense, like if I want to establish like what do I mean by that, I think I could say that distance right there is going to be 1/2 the width of one of these books, and we're assuming that the books are equal width because it says two books of width W there, but that's already half. So then the question is, well, where could I put the edge of the table underneath here where at some point the whole thing would like not tip over, right? And maybe I can apply the same concept of center of mass must be over the support base. And the moment when center of mass gets outside that support base, that's when balance is lost, right? So I'm not going to draw the table in yet, but what I am going to draw is I'm going to say, hey, this point right here might represent the center of mass of the lower book, right? So these are the respective center of masses of these two books. But now if I say, well, what is the center of mass of this system combined, since the two books are basically equal, identical books as far as we know, it makes sense that their center of mass point would be some point kind of halfway in between, maybe like right here, right? Which would mean that since this point is halfway along in the bottom book, and this center of mass point is halfway between that and where the other center of mass point of the first book is kind of above the edge of that book, I think it makes sense that this kind of additional distance right here, that would be 1/4 W, and that's where the edge of the table could be. Oops, that wasn't very good for a table. Maybe a very stylized table, right? But that's where it could be sitting on that table. I'm not going to draw the rest of it. So if I look at that total distance D, right, between here and here, I've got 1/2 W, 1/4 W. So I think that's going to be 1/2 plus 1/4 is 3/4 W. So that's my answer right there, 3/4 W. We can go ahead and check that now and see that that is correct. And it's kind of cool how you could arrive at that in a very conceptual kind of way based on the idea of stability and how that relates to where the center of mass is to the support base of an object or even a two-object system.